Hello everyone. Today we are talking about maintenance and repair of storage systems and batteries. As you can see on the screen, our content is for today. The storage systems. Concepts and types of storage systems. The concept of the battery. Battery types. Battery operating principles. Use of batteries. Batteries and storage systems. Relationship between batteries and storage systems. The role of batteries and storage systems. Maintenance and repair. General guidelines. Maintenance procedures. Repair processes. Let's start with the storage systems. First of all, concepts and types of storage systems. Storage systems are equipment or systems designed to store energy, materials or data for extended periods of time. Storage allows energy or materials to be used or distributed for later use. Storage systems are widely used in various fields such as energy supply, industry, construction, logistics and data management. 1. Pumping reservoirs. In such storage systems, water energy is stored by pumping water to higher levels in reservoirs and then extracting hydroelectric energy from the water as it is drained. 2. Hydrogen storage systems. Hydrogen can be stored in different ways, for example under pressure or as a compound, e.g. in the form of hydrogen-forming substances. 3. Thermal storage systems are used to store thermal energy for later use. For example, heat accumulators or heat storage materials can be used to store thermal energy from solar collectors or geothermal sources. 4. Chemical storage systems. Various chemicals or compounds can be used for energy storage, such as brine batteries, redox circuits or hydrogen fuel cells. These are just a few examples of storage systems, and the technologies and methods used offer a wide range of options for storing energy or other materials. The design and selection of storage systems depends on the specific application, the energy or material requirements, the quantity to be stored and other specific requirements. The selection and effective maintenance of the right storage system is key to efficient operation and economical use. Let's continue with the concept of the battery. Batteries are devices that can store electrical energy and supply it for later use. Batteries work through chemical reactions in which electrical charges move in the cells of the battery. Batteries are widely used in various applications such as portable electronics, vehicles, households and energy storage systems. Some common battery types are 1. Lithium-ion batteries. These are the most common batteries used in portable electronic devices. They are the most common type of batteries used in the most common automotive applications. 2. NICD batteries. NICD batteries are commonly used in industrial and commercial applications. They have the advantage of high cycle life and stable performance, but are less desirable from an environmental point of view due to their cadmium content. 3. NIM batteries. NIM batteries have a higher energy storage capacity than NICD batteries and are more environmentally friendly. They are often used in portable electronics and hybrid electric vehicles. 4. Lead-acid batteries. Lead-acid batteries are often used in starting and ignition systems and solar energy storage. These conventional, heavy batteries are reliable and inexpensive, but have a lower energy storage capacity. Our next topic is the battery operating principles: charge-discharge. During discharge, the battery operates like a galvanic cell. During the charge separation process, the material of its electrodes is transformed. During charging, the battery absorbs energy and its electrodes are transformed. The positive active electrode is oxidized, the negative is reduced and absorbs electrons. These electrons create the charge current in the external circuit. The electrolyte functions either as an electron buffer, Li-ion, NICD, or as an active participant in the reaction. Principle of operation of a lead-acid battery. 3 active substances play a role in its operation. Is the metal lead, Pb, which is the negative electrode during operation, in the form of a spongy metallic lead plate on a lead grid. Is lead oxide, PbO2, which is the positive electrode in the form of a sponge plate on an electrically conductive lead grid. Sulfuric acid, H2SO4, also known as electrolyte, which surrounds the plates and fills their pores. Electrolyte, dilute sulfuric acid. When charged, anode, lead, cathode, lead oxide, PbO2. On discharge, both electrodes are converted to lead sulfate. The nominal voltage of an operating cell is 2V. By connecting the cells in series, batteries can be formed, e.g. 6 cells 12 volts. Common battery type. Its low internal resistance allows the difference between the charging and discharging voltages to be kept to a minimum, so that it can be charged during operation. Consumers are not damaged in the process. Problems. Water splitting above 2.39 volts, produces Burr gas, battery may explode. Pollution, lead. Operating principle of an oxygen combination sealed lead-acid battery. Design change in the 1990s, widespread adoption. Used in uninterruptible power supplies for cars, computers and alarms. Applications for gel batteries have narrowed in the present day. This is due to the relatively small capacity and low load capacity associated with their large size and weight. Nickel-cadmium battery, NICD, principle of operation. Some types require a very high discharge current. It is important to highlight the toxicity of cadmium. These batteries lose their charge without consumption, self-discharging. The principle of the memory effect is based on the principle that the battery remembers the discharge point. In the case of incomplete discharge, it will only operate at a lower voltage after the discharge point due to crystal formation. During the process of crystallization, the active particles of the battery tend to form larger crystals, which leads to a reduction in capacity. To achieve maximum life in use, it should be fully discharged each time before charging. Self-discharge is low and fast charging is relatively well tolerated. Nickel metal hydride, NiM, battery working principle. Like NICD batteries, nickel is on the positive side, but on the negative side a special hydrogen bonding metal alloy, nickel oxide hydroxide, NiOOH, replaces the cadmium. When charging, this metal alloy binds the hydrogen in the acid electrolyte and releases it when discharging. It has a voltage of 1 to 1.5 V. It can store 2 to 3 times the energy of nickel-cadmium for the same size. Charging is much more complicated. To achieve the correct charge level, a complex charging algorithm is required that takes into account the temperature of the battery. This makes charging circuits more expensive. Their memory effect is practically negligible. Lithium-ion, Li-ion, battery operating principle. The charge is stored by lithium ions which migrate to the negative carbon-based electrode when charging and to the positive metal oxide electrode when discharging. The anode and cathode are separated by an organic electrolyte. The capacity and cell voltage is twice that of a NICD battery. Even a depleted cell can supply at least 3 volts. When fully charged, the cell voltage is about 4 volts. Their advantage is their low weight. No crystallization is observed. Lithium polymer battery working principle. The successor of the Li-ion is the lithium polymer, Li polymer, battery. It has the advantage of containing no or very little liquid electrolyte, instead a special polymer separates the anode and cathode. This can result in very thin and flexible cells, as there is no need for a thick-walled casing to protect against liquid leakage. Batteries can be widely used in various fields and applications for the storage and subsequent use of electrical energy. Batteries allow these devices to operate wirelessly and are easily portable. 1. Electric vehicles. In electric vehicles, including electric cars, hybrid cars and electric bicycles, batteries store and deliver the electrical energy to power the vehicle. Batteries are essential for promoting electric mobility and reducing dependence on fossil fuels. Portable electronic devices. Batteries are widely used in smartphones, tablets, laptops, MP3 players and other portable devices. Batteries allow these devices to operate wirelessly and are easily portable. 2. Ships and shipping. Batteries play an important role in the electrical systems of ships. They store energy for the operation of the ship, including lighting, navigation equipment, communication equipment and other electrical systems. 3. Electricity storage systems. Batteries are used in energy storage systems that allow energy to be efficiently stored and used later. This can help to smooth out fluctuations in renewable energy and improve the stability of electricity grids. 4. Households. Batteries can be used in household applications, such as solar PV systems, for energy storage and as a standalone power source for emergency or backup power. 5. Industrial applications. In industrial areas, batteries are used to power machines, robots, hoists and other equipment and to ensure stable operation of processes. Batteries have many other uses and are constantly evolving as new technologies and applications are developed. Their main advantage is that they provide a mobile source of energy and enable electricity to be delivered to the site where it is needed. This facilitates wireless and portable devices, sustainable transport and energy storage for efficient use of renewable energy sources. Reality. Michael Faraday, a 19th-century English scientist and physicist, carried out a number of experiments in electricity and electrochemistry that contributed to our understanding of how batteries work. Here are some of Faraday's important experiments on batteries. Electrolysis experiments. Continue with batteries and storage systems. What is the relationship between batteries and storage systems? Storage systems and batteries are linked in different ways. Batteries are often used as part of storage systems, which allow electricity to be stored for longer periods of time and used later. Storage systems can be used to optimize the energy transfer and performance of batteries and to regulate energy production and use between different energy sources. Some examples of the link between storage systems and batteries. 1. Solar PV systems. In solar PV systems, batteries store the solar energy produced by the solar panels. This allows for later use of solar energy, for example at night or during cloudy periods when the solar panels produce less energy. 2. Off-grid systems. In off-grid systems, batteries store surplus energy produced by different energy sources such as solar panels or wind generators. This allows energy production and use in off-grid mode when grid electricity is not available. 3. Electric vehicles. In electric vehicles, batteries store the electrical energy produced in the vehicle or collected from charging stations. This allows the vehicles to be driven and the energy to be stored and used later during the charging cycle. 4. Energy storage systems. Energy storage systems, ES, are designed to store energy and ensure grid balance. ES use batteries to store energy, which allows for the balancing of time differences between grid load and energy demand. Maintenance and repair of batteries and storage systems is important for optimal performance and lifetime. Storage systems and batteries play a key role in various applications such as renewable energy integration, electric vehicles and portable electronics. They play a prominent role in energy production, conversion and use. They enable energy to be stored for later use or transport and contribute to energy efficiency, reliability and sustainability. 1. Energy storage. Batteries and storage systems enable the storage of electrical energy or other forms of energy such as heat or hydrogen. This allows balancing of energy production and use over time, which is particularly important for balancing the fluctuations of renewable energy sources such as solar and wind power. 2. Energy conversion. Batteries and storage systems enable energy conversion between different forms of energy. For example, solar energy can be stored in batteries and converted into electricity for later use. 3. Balancing energy consumption. Batteries and storage systems help to balance load and energy consumption. For example, energy storage systems can use energy stored during peak hours to reduce load on the grid and distribute the load throughout the day. 4. Backup power. Batteries and storage systems can provide backup or emergency power when the grid is interrupted or disturbed. This provides power for sensitive equipment and systems, such as critical infrastructure or healthcare facilities. 5. Mobility. Batteries play a key role in electric vehicles, enabling more sustainable and greener transport. Batteries enable electric vehicles to be powered and store and transport energy with high efficiency. 6. Energy independence. Batteries and storage systems offer the possibility of energy independence in places or situations where there is no access to conventional energy sources or where the energy supply is unstable. This allows for the creation of self-sustaining systems, such as off-grid solar PV systems or in remote areas. Batteries and storage systems therefore enable flexible and efficient management of energy, integration of renewable energy sources, improving energy efficiency and promoting sustainability. Technological development and innovation are constantly evolving these systems to make them even more efficient and economical and to contribute to the transformation of the energy world. Finally, about the maintenance and repair. The maintenance and repair of storage systems and batteries are important tasks to maintain their efficiency, extend their lifetime and ensure their reliable optimal operation. Here are some general guidelines and things to do to maintain and repair storage systems and batteries. 1. Regular inspection. Inspect storage systems and batteries regularly to identify potential problems such as leaks, corrosion, damaged cables or connectors. Also check voltage and capacity measurements. 2. Cleaning. Keep the external surfaces of storage systems and batteries clean. Remove any dirt, dust or oil that may be present to help prevent corrosion and electrical insulation problems. Check battery cells. Inspect the condition of each battery cell, check the electrolyte level, if applicable, and replace with purified water or electrolyte if necessary. 4. Check and clean connectors. Check the connectors on storage systems and batteries for loose or corroded parts. Clean connectors if necessary and tighten bolts or nuts. Avoid constant charging and discharging. Avoid full discharge of batteries for long periods of time and constant charging for extended periods of time, as these conditions can damage batteries and shorten their life. 6. Replace defective batteries. If you notice any defects in the batteries or storage systems, such as damaged or exhausted batteries, replace them with suitable new ones. 7. Professional repair. For more complicated problems or malfunctions, contact a professional or the manufacturer. Do not attempt to carry out repairs without adequate professional knowledge and experience. It is important that storage systems and batteries are properly maintained and repaired, and that the manufacturer's recommended procedures and safety standards are followed. We have to talk about the repair processes. 1. Diagnosis. The first step is to determine the cause and extent of the problem. This may include performance testing, testing of charge and discharge cycles, and checking the physical condition and connections. 2. Cell or module replacement. Batteries usually consist of several cells or modules. If only one cell or module is defective, they may need to be replaced. A technician will be able to identify the faulty batteries and replace them. 3. Repairing electronic controls. Batteries and storage systems usually use electronic controls to regulate charging and discharging. If the electronic controller is faulty, it may need to be repaired or replaced. 4. Proper maintenance and cleaning. Some problems, such as poor connection or contamination, can be solved simply by maintenance or cleaning. Check the connections, clean any dust or dirt, and ensure that regular maintenance activities are carried out. 5. Safety considerations. It is important to note that batteries and storage systems can be dangerous and special safety precautions must be followed during repair. This may include electrical safety, proper insulation, proper ventilation and the use of appropriate protective equipment. Today's lesson is based on the references and resources listed here. As we come to the end of our lesson, I would like to thank you for your attention and wish you a good learning experience.